Okay, in this video, we are going to be looking at question 4, part 1 of the June 2014 FP1 Edexcel paper. And the question says that given these two matrices here, you've been given A and you've been given B, it's asked us to find AB. This is just matrix multiplication, because remember, just like algebra, this is how we write matrices being multiplied together. We don't bother writing A times B, we just tend to write AB, just like we would in algebra, because it's two letters being multiplied together. Okay, now matrix multiplication, it's one of these weird things that, I appreciate the first time you ever meet matrix multiplication, you can think, oh, that's weird. And you just kind of think to yourself, oh, I just got to remember the process, because it's one of those things you have to do. So what I'm going to try and do in this video is kind of convince you of why it should be the case, the kind of process, and goes into a little bit more detail, and try and, because sometimes if you convince yourself that, that a process should be like that, then it kind of sits better with you and it makes it easier to remember the process. So there is a little bit more to this, but for the meantime, all I want you to think is when you're doing matrix multiplication, it's rows multiplied by columns. Rows come first, columns come second. It's just like when you're looking at a graph, okay, or looking at a set of coordinates. Rows come first, columns come second. Okay, it's exactly the same thing as matrix multiplication, because of course a matrix is just a table of numbers, and you can break that table up into rows and columns. So for the meantime, I just want you to think, right, rows times columns. So A times B, we want to split the first matrix up into rows, which you can see I've done so here by colour coordination. So first row I've got 1, 2, which is represented by blue. Second row is 3 minus 1, which are represented by green. And third row is the 4 and the 5, which are represented by purple. And the second matrix is the B, and we're going to split that matrix up into columns. So we've got a red column, a yellow column, and an orange column. Okay? So the first column is 2, 1. Second column is minus 1, 3. Third column is 4 and 1. Okay? Just to really make that clear. And then I've produced this little table. Okay, so I've got the rows down here. This is our A, okay, in this instance. So I've got our rows. I've got the blue row, the green row, and the purple row. And I've got columns. And this is our B matrix. So I've got the red row, the red column, the yellow column, and the orange column. Okay, and this just shows how the elements kind of come together. So I've got a bit of the blue and a bit of the red, then a bit of the blue and a bit of the yellow, and then a bit of blue and a bit of the orange. And you can see that, the columns, the rows, match up, and the columns sort of match up. So I've got blue, blue, blue. Then I've got red, 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 yellow, 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 orange, 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 green, 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 purple, purple, purple. Okay, so, rows and columns. If you can't quite see that, then maybe an example will sort of help to clarify things. So I've got the same matrices that's up here, and I've copied that down, and I've copied the table as well. Okay, and now I want to talk a little bit about what's actually going on with matrix multiplication, because this sort of table is a really good indication of which kind of elements go together. But there's a little bit more to how they go together, and it's called element-wise. So you basically multiply, you look at, okay, so the first position, this is the first row and the first column. Okay, that's this position in the AB matrix. First row, first column. Okay. And so you look at the first row of the first matrix, which is the A, and the first row of the second matrix, which is this one of the B, and you basically multiply element-wise. So what do I mean by that? It's first elements being multiplied together plus the second elements being multiplied together. So first element of the first row in the A multiplied by the first element of the first column in the B, and then I want to add that to the second element of the first row times the second element of the first column. It gets a bit of a mouthful. Maybe it's just easier just to see it. Okay, so we've got 1 multiplied by 2 plus 2 multiplied by 1. Okay, and that's all that goes in there. Okay, and let's look at the first column, the first row and the second column. I'm getting my rows and columns confused. I do apologise. First row's second column. So I'm looking at the first row of A multiplied by the second row of a second column of B. I did it again. I'm sorry. So we got 1 multiplied by minus 1 plus 2 multiplied by 3. Okay, And then here we got the first row, third column. So we got first row of A, which is the 1 and 2. And then we got the third column of B, which is 4 and 1. So we got 1 multiplied by 4 plus 2 multiplied by 1. Okay, and then let's move on. So we got down here, we got second row multiplied by first column. So second row of A multiplied by first column of B. And then we've got, here we got second row, second column. So second row of A multiplied by second column of B. Here we got the second row, third column. So second row of A multiplied by third column of B. And then down here we got third row of A multiplied by first column of B. So third row, second column here. So third row of A multiplied by second column of B. And down here we got third row, third column. So third row of A multiplied by third column of B. Okay, so now let's just put it all together. So I'm going to actually try and do it without, you can use this, but once you get used to it, you can actually just take a shortcut. You can just look at these two matrices. You can kind of, the process, and you just kind of do it. So 1 multiplied by, so I'm going to try and do it without using this matrix here. But of course, if you have to write this matrix down, fine. But I'm going to try and do it in my head. Of course, you have got a calculator in your hand as well, so that can help you remember the numbers by just typing them into the calculator. But I'm going to try and do it in my head. So here goes. We got 1 multiplied by 2, which is 2, plus 2 multiplied by 1, which is 2. So in the first row, first column, we got 4. Okay. So first row, second column we're going to use next. So we're going to use first row of A, second column of B. So 1 multiplied by minus 1, which is minus 1, plus 2 multiplied by 3, which is 6. We've got minus 1 plus 6, which is 5. And then we got first row, third column. So we got 1 multiplied by 4 plus 2 multiplied by 1. So we got 6. Okay. Now second rows now. First column. Second, if we got 3 multiplied by 2, which is 6, plus minus 1 times 1, which is minus 1. So we got 5. And then we got 3 multiplied, so it's still second row, but this time it's second column. So we got 3 multiplied by minus 1, which is minus 3, plus minus 1 times 3, which is minus 3. So we're going to end up with minus 6. And then we got 3 multiplied by 4, which is 12, plus minus 1 times 1, which is minus 1. So we got 6 plus minus 1. Is that right? Yeah, which is, 3 multiplied by 4, that's 12, isn't it? Minus 1 times 1, that's minus 1. So we're going to end up with 11. Okay? Then finally, we got 4 multiplied by 4, which is 16, plus 5 times 1, which is 5. So we've got 21 here. Have we? Sorry, what am I doing? I do apologise. That's 21 goes here. That's what I was doing. For some reason, I was doing third row, third column. Okay, let's do this element here, which is third row, first column. So we got 4 multiplied by 2, which is 8, plus 5 multiplied by 1, which is 5. So we got 8 plus 5, which is 13. And then we got 4 multiplied by minus 1, which is minus 4, plus 5 times 3, which is 15. So we've got 11, which goes in here. And that's our matrix. This is A times B. Now, if you don't have to use this matrix here, great. Okay. If you can kind of just remember what goes in your head, it will come natural to you once you kind of do more and more. But yeah, I mean, ultimately, you want to just do what I just did here, which is just produce this matrix. And once you do loads of them, it kind of comes second nature to you. So where are the marks? Well, the first mark is just producing a 3 by 3 matrix. Okay, with numbers in them. Okay, you can't just say it's a 3 by 3 matrix. You have to kind of put numbers in a 3 by 3 matrix and show that you've at least attempted to calculate it. Even if you get the wrong numbers, as long as you produce a 3 by 3 matrix with numbers in, they will give you 1 mark out of 3. The second and third mark comes from, it's 3 marks for this whole question, for part A. The second and third mark basically are kind of like error marks. Okay, so if you get the full matrix, you get the extra 2 marks. But basically you get a mark, if you get one element wrong, you only get 1 mark. Okay, so there's 2 marks available. If you get the full work matrix all correct, you get 2 marks. If you get one element wrong, but all the rest right, you get 1 mark. If you get 2 elements wrong, but the rest right, you'll still only get 1 mark for producing a 3 by 3 matrix. Okay, now, part B. I'll just clear that. That was my earlier working. Okay, part B, it's saying why is AB not equal to BA? Well, if you remember, AB, A is a 3 by 2 matrix and B is a 2 by 3 matrix. Remember, it's rows and columns. That's all the time. So number of rows in A is 3. Number of columns in B is 2. Okay, let's look at B. Number of rows in B is 2. Number of columns in B is 3. Okay, so A is a 3 by 2. Is a 3 by 2 matrix. And B is a 2 by 3 matrix. Okay, so AB is doing a 3 by 2 matrix multiplied by a 2 by 3 matrix. Okay, and remember with matrices, in order to multiply the matrices, these two inner numbers have to match. Okay, and the outer two numbers will give you the dimension. Right, so a really quick way of telling whether a matrix is you're able to multiply a matrix is seeing whether these two numbers match. If they do, then you can multiply it, and the outer two will give you the dimension. Okay, but let's look at so AB. Inner two numbers, they match, so we can do that, and the outer two numbers give us a 3 by 3 matrix. So now AB will be a 3 by 3 matrix. Okay, now let's look at B times A, which is what we want to show that it's not the same as A times B. Well, B times A is the same as doing a 2 by 3 matrix, and we multiply that by a 3 by 2 matrix. So the inner two numbers match, which means we can do the multiplication. But look at the outer two numbers, the dimension. It's going to result in a 2 by 2 matrix. Well, 3 by 3 matrix, you get a 3 by 3 matrix from doing AB, but from BA, you get a 2 by 2 matrix. Okay, so the two matrix dimensions are not the same. Okay, so therefore, you're not going to get the same matrix as AB if you do BA. Okay, you don't actually have to compute the matrix. I mean, some people would be inclined to compute what BA is, just like we did with AB, and show, well, it's not the same matrix, so you can't do it. So they're not the same. But remember, we've just been asked to show that we can multiply matrix, we can do matrix multiplication in the first part, in part A. So they wouldn't ask you to do it again, especially not for 1 mark, because this is all that question's worth. So all you have to basically say is matrix multiplication is not commutative, or AB results in a 3 by 3 matrix. BA results in a 2 by 2 matrix. Since these two dimensions are not the same, then AB is not the same as BA. No matrix multiplication computed there. We haven't computed BA. We've just said, just purely looking at the dimensions. Nice, easy 1 mark.